Standard form for a quadratic is y equals ax minus p squared plus q. And we know that our a stretches and compresses, p is your horizontal translation, and q is your vertical translation. So on the diagram, if this was our quadratic, our vertex here would be p comma q. So however much you've been translated p or q amounts, your axis of symmetry is x equals p, and it will be congruent to ax squared. So whatever it is, stretched or compressed. So writing an equation from a graph. First you need to find your vertex. So our vertex for this graph is 4, negative 2. That means our p is equal to 4 and q is equal to negative 2. So we would write this into our equation, x minus 4 squared minus 2. Now we need to find our a, but we don't know a. But what we do know is that this point on the graph, or here, p of 2, negative 14, is a point. So we're going to substitute these in for our x and our y. So my y is negative 14, 2 is x, and we're going to simplify. 2 minus 4 is 2, squared is 4, so we have 4a minus 2. Now we're going to add 2 to both sides. We have negative 12 equals 4a. Divide both sides by 4. Negative 3 is equal to a. So now we have our a and our p and our q. So our equation is y equals negative 3x minus 4 squared minus 2. And that's our final equation for this graph. To graph an equation, we want to find our vertex. Oops. Vertex will be 3, 1. The direction is up. The axis of symmetry is x equals 3. Our intercepts, to make our y1, we are going to make x equal to 0. So we have y equals 9 over 4. 3 times 3 is squared. So that would be 9 times 1 over 4 is 9 over 4 plus 1. So y equals 3.25. Our x-intercept would be 0 equals 1 over 4 x minus 3 squared plus 1. We're going to subtract 1 from both sides. Times both sides by 4. Now from here we want to take the square root of both sides, and because this is a negative, we have no real roots, so there's no x-intercepts. The domain will be x. That looks really not good at all. X is an element of all the real numbers, and y, because we have a minimum and it's up, y will be greater than or equal to 1 for all the real numbers. So to graph this, we know that it's going to be at the point 3 and 1. So here's our vertex, and it crosses at 3.25. So it's going to look something like that. Determining an equation from characteristics. So the equation of an axis of symmetry is x equals 3, and it goes through the points negative 1 and negative 6, and 5 and 0. So we know that because this is 3, our p is equal to 3. Let's do this in a different color. So if we substitute this in, y equals ax minus 3 squared plus q. We don't know a or q, so what we're going to have to do is we're going to substitute in both points separately, and then we're going to solve for a and q. So negative 6 equals a negative 1 minus 3 squared plus q. negative 6 equals negative 1 minus 3 is 4, so we have 16a plus q. So this is our first equation. Our second equation is 0 equals a 5 minus 3 squared plus q. 5 minus 3 is 2, squared is 4, so 0 equals 4a plus q. Now, in order to solve with two systems of linear equations, we're going to use substitution, so we need to get either q or a by itself. And the easiest one to do this is right here, to minus 4a to equal q. So this is our second equation. Now we're going to sub 2 into 1. So if we substitute a q equals negative 4a in here, that means that we're going to have 16a, and instead of writing q, we're going to write minus 4a. So negative 6 is equal to 12a, divide by 12, a is equal to negative 0.5. Now we need to find our q, so we're going to substitute it in for a. So negative 4 times 0.5 negative equals q, so 2 equals q. Now we have q, a, and p, so our equation is y equals negative 0.5 x minus 3 squared plus 2. And that's okay. A 12-meter long bridge is made with ropes and logs. The rope forms a parabola with its lowest point 2 meters above the center of the bridge. The ropes are attached 6.5 meters above the bridge. Determine the equation to model. So if you looked at this, this side would be your supports with your logs, and your parabola with the rope is going to be on the inside. So we're going to go up by ones. So this is 12-meter long bridge, and 1, 2, 3, 4, 5, 6. This is 6, and this is 7. So we know that halfway between the bridge is the lowest point, and it's 2 meters above. So half of 12 is 6. So here is our vertex, and it's 6.5 where the ropes are attached, here and here. So this is our parabola. That looks bad. There we go. Something like that, but nicer. So the vertex for this question would be 6, 2. P would be equal to 6. Q would be equal to 2. A point that we have on the graph could be right here or right here. So 0 and 6.5. So our x is this, our y is this. So we're going to substitute that in. So y, what's our y? 6.5. So 6.5 equals a 0 minus 6 squared plus 2. 6 squared is 36. Subtract 2 from both sides. Divided by 36. And if you type this into your calculator, 4.5 divided by 36, you should get 0.125. And then go second function, ABC, and you should get 1 over 8 as your a. So the equation for our line will be y equals 1 over 8, x minus 6 squared plus 2. For the last one, a cable that supports a suspension bridge is parabolic. The horizontal distance between the ends of the cable is 140 meters. The midpoint of the cable is 14 meters below each of the endpoints. So this time, we have a bridge like this. If we go up by 2s, 4, 6, 8, 10, negative 4, negative 8. We know that the midpoint is the lowest point of the graph, and it's at our vertex. And we know that the ends of the bridge are at 14, and they're at 70. So at 70 and 14, we have the endpoints. This is our parabola. So the vertex is 0 and 0, and our point is 70 and 14. So we could use this point or this point, doesn't matter. So if we substitute this into the equation, y equals a x minus 0 squared plus 0, and our x is 70. All we're left with is 14 equals 49,000 a, divide by 4,900, not 49,000. And you should get 1 over 350 when you simplify it equals a. Because p and q are 0, our equation you don't need to write them in. So all you have to put is 1 over 350 x squared. And that's our equation of our line.